Have you ever wondered what would happen if we discovered a treasure worth more than all the money on Earth combined? Well, we already have. It's floating in space right now, completely out of reach. Today we're embarking on an incredible journey to asteroid 511 Davida, a cosmic gold mine worth an estimated $27 quadrillion. That's more wealth than has ever existed in human history, all packed into a single space rock. Did you know that this one asteroid contains enough precious metals to make every person on Earth a multi-billionaire? Yet despite this mind-boggling wealth, we'll never be able to mine it. Stick around, because what you're about to discover will change how you think about space exploration and humanity's future among the stars. By the way, if you're enjoying this cosmic journey, a quick like really helps the channel reach more space enthusiasts like you. Let's dive into why the ultimate payday remains forever out of our grasp. First, let's grasp just how massive Davida really is. This isn't some pebble floating through space. It's a monster. Davida stretches 289 kilometers across. Imagine driving from Las Vegas to Phoenix, except instead of desert, you're crossing solid rock and metal hurtling through the cosmos. To put that in perspective, if you could somehow place Davida over Switzerland, it would completely cover the entire country with room to spare. This cosmic behemoth takes 5.61 years to orbit our sun, spinning like a giant celestial top once every 5.13 hours. Picture standing on its surface. The sun would race across the sky so fast that you'd experience 5 complete days in the time it takes to watch a movie marathon. Talk about jet lag. But here's where things get truly staggering. Davida weighs approximately 38.4 quintillion kilograms. How much is that really? Well, imagine stacking 400 million Empire State Buildings on top of each other, then compressing them into a single object. That's Davida, the 5th most massive asteroid in our solar system, containing about 1.5% of the asteroid belt's total mass. Now for the part that makes economists' hearts race. What's inside this cosmic treasure chest? Davida is what we call a C-type carbonaceous asteroid, which sounds boring until you realize what that means. We're talking about water, iron, nickel, cobalt, and most importantly, platinum group metals that are essential for our modern technology. Interested Sykes Davida contains enough platinum alone to supply Earth's needs for millions of years. Add in the gold, silver, and rare earth elements, and you're looking at resources that could transform human civilization. But here's the sobering reality. It might as well be in another galaxy for all the good it does us. The first massive hurdle is distance, and it's a doozy. Davida doesn't conveniently orbit near Earth like some asteroids. Instead, it lives in the main asteroid belt between Mars and Jupiter, currently sitting about 531 million kilometers away. Even at its closest approach to Earth, it never gets nearer than 238 million kilometers. Want to know how far that really is? The Moon, humanity's farthest destination, is only 384,000 kilometers away. Davida, at its absolute closest, is still over 600 times farther than the Moon, and we've only managed to send 12 humans to the Moon in all of history. In the language of rocket scientists, we measure mission difficulty using something called delta V, basically how much speed change you need. Near-Earth asteroids require about 3 to 6 kilometers per second of delta V. Davida, you're looking at over 14 kilometers per second. That's like comparing a neighborhood bike ride to pedaling across the Pacific Ocean. Even with our most advanced spacecraft, we're talking about a minimum 2-year journey each way. Add in the time needed for mining operations, and you're looking at a 5 to 7-year mission. That's assuming nothing goes wrong, which, let's face it, something always goes wrong in space. Speaking of things going wrong, have you ever tried to hammer a nail while both you and the nail are floating? That's the challenge of mining in microgravity. On Earth, mining depends on gravity. Rocks fall, equipment stays put, debris settles. In space, everything floats, including the multi-ton boulders you just blasted loose. Then there's the communication delay. Signals between Earth and Davida take 20 to 40 minutes each way, depending on orbital positions. Imagine trying to operate heavy mining equipment with a 40-minute delay on every command. It would be like performing surgery while watching a video feed from half an hour ago. But let's say we somehow solve all these technical challenges. We develop nuclear propulsion, create autonomous mining robots, and figure out zero-gravity ore processing. The economics would still kill the project before it even started. Conservative estimates put a single Davida mining mission at $50 or $100 billion in development costs. That's more than the GDP of Kenya or Luxembourg invested in one incredibly risky venture. And here's the cruel twist: success would be its own punishment. What happens when you flood Earth's market with more platinum than has ever been mined in human history? Economic models show that large-scale asteroid mining could crash commodity prices by 50% or more overnight. The very abundance that makes Davida attractive would destroy its value the moment we succeeded. So what are we actually doing about asteroid mining? Smart companies and space agencies are targeting much easier prey. Near-Earth asteroids like Bennu come within 300,000 kilometers of Earth, practically next door in cosmic terms. These rocks might not have Davida's massive wealth, but at least we can actually reach them. Japan's Hayabusa missions proved it's possible. They visited asteroids, collected samples, and brought them home. Sure, they only returned a few grams of material, but those few grams proved the fundamental concept works. It's like the Wright brothers' first flight, not impressive by today's standards, but revolutionary for its time. Even if we had the technology and economics sorted out, we'd face a legal nightmare. The 1967 Outer Space Treaty says no nation can claim celestial bodies, but it's frustratingly vague about mining rights. Only 5 countries have passed laws allowing their citizens to own extracted space resources. What happens when multiple nations show up at the same asteroid? Who enforces property rights 300 million miles from Earth? Which court handles disputes in the asteroid belt? No insurance company on Earth would cover a trillion-dollar mining operation with unlimited liability. The legal framework simply doesn't exist for operations of this scale. But here's something beautiful about impossible challenges: they don't stay impossible forever. 50 years ago, the idea of private companies sending rockets to space stations seemed like pure fantasy. Today, SpaceX does it routinely. Nuclear propulsion is advancing, with NASA planning demonstration flights by 2020. Autonomous systems grow smarter every year. Each restful mission teaches us something new, bringing us incrementally closer to the day when main belt mining might make sense. The real value of Davida isn't the money at all. Perhaps it's meant to be used in space, not brought back to Earth. If humanity truly wants to become a spacefaring civilization, with bases on Mars, massive space habitats, missions to the outer planets, we'll need resources from somewhere besides Earth. Will we mine Davida in our lifetimes? Almost certainly not. Will our great-grandchildren look back and laugh at how we thought it was impossible? Maybe. The history of exploration is full of impossible dreams that became routine reality. So there it is, the ultimate space paradox. Davida sits out there, containing more wealth than humanity has ever possessed, yet remaining completely beyond our reach. The distance is too vast, the technology too primitive, the economics too problematic, and the laws too vague. Perhaps that's exactly as it should be. Davida represents something profound, a reminder that the universe is full of wonders beyond our current grasp, but not beyond our imagination. Every impossible challenge eventually becomes possible through persistence, innovation, and time. Today's baby steps with near-Earth asteroids are tomorrow's giant leaps to the main belt. We're learning to walk before we run, developing the tools and wisdom we'll need for greater adventures ahead. What do you think? Will humanity eventually crack the code to asteroid mining, or will treasures like Davida remain forever out of reach? Share your thoughts in the comments below. I love hearing different perspectives on humanity's future in space. Thanks for joining me on this journey to the cosmic treasure we can't quite touch. If you want more mind-blowing space content, hit that subscribe button and ring the notification bell. Until next time, keep looking up and wondering what's possible. The universe is full of impossible treasures, waiting for the day when impossible becomes inevitable.